AI is just a computer program, right? And quantum computing is like super AI, right? And spatial computing. Isn't that just VR? Wrong. If you've ever confidently explained these technologies at a tech meetup, or if you're an engineer who swears they already know, buckle up. Because today, we're breaking down one of the most misunderstood debates in modern technology: AI versus quantum versus spatial computing. And trust me, if you think you already understand it, there's a good chance you've been oversimplifying or pretending. Welcome to Beyond Tech Hype, the channel where we cut through the buzzwords, the marketing hype, and yes, even expert overconfidence to actually understand innovation. Let's start with the foundation, the humble computer. A computer is nothing magical. At its core, it's a machine that takes input, processes instructions, and produces output. It works with bits, little switches that are either 0 or 1. That's it. Whether it's a massive supercomputer predicting the weather or the microcontroller inside your toaster, all computers boil down to manipulating zeros and ones really, really fast. Here's the truth. Computers themselves are dumb. They don't understand, think, or reason. They're just following instructions step by step. The magic isn't in the machine. It's in the software we write, the algorithms. Without software, a computer is just a fancy paperweight made of silicon, copper, and plastic. So first truth bomb, a computer is a tool, nothing more, nothing less. Powerful? Absolutely. Magical? Not even close. This is where confusion starts. Because when you add sophisticated algorithms, computers start behaving in ways that look intelligent. Which brings us to our first real player: artificial intelligence. Artificial intelligence, or AI. The word alone makes headlines, investors excited, and tech enthusiasts either thrilled or terrified. So, what is AI really? AI is not a computer. AI is software. Algorithms that let a computer learn patterns from data. Instead of programming every single rule, we feed the AI examples and it figures out the patterns. For instance, classical programming. You tell the computer exactly how to identify a cat: two triangle ears, whiskers, four legs, tail. AI. You feed the system millions of cat pictures. Eventually, it learns the features itself and says, "Ah, this is probably a cat." AI is math plus data plus compute. That's it. It's glorified pattern recognition. Important note: AI does not think. It does not understand. It doesn't have consciousness. It just predicts, classifies, or generates output based on patterns. So when people say AI is a computer, that's wrong. The computer is the hardware. AI is the software. One is a tool, the other is what you do with the tool. And when people say AI is taking over everything, remember, AI doesn't run on its own. It runs on computers. Hardware plus algorithms equals what we call AI in applications today. Now let's enter the second player, quantum computing. Quantum computers are not AI, and they are not just faster classical computers. They are a completely new kind of machine built on quantum mechanics. Classical computers use bits, 0 or 1. Quantum computers use qubits, which can be 0, 1, or both at the same time, a property called superposition. And qubits can be linked through entanglement, meaning changing one qubit instantly affects another, no matter how far apart they are. What does this allow? Quantum computers can explore huge solution spaces exponentially faster than classical machines, at least for certain problems. Cryptography, breaking encryption that would take classical computers billions of years. Material science and chemistry, simulating molecules for new drugs, batteries, or materials. Optimization problems, logistics, supply chains, and even some AI training tasks. Here's the kicker. Quantum computers today are experimental, fragile, and noisy. They crash if a scientist sneezes in the lab. So no, they won't replace your laptop or ChatGPT tomorrow. Truth bomb, quantum computing is a new kind of hardware. It's not AI, it's not magic, and it's certainly not a super brain. It's a specialized machine for specific types of problems, and it's still early days. Finally, let's talk about spatial computing, the new kid on the block. Spatial computing is about computers that understand and interact with the 3D physical world. It's the technology behind AR, VR, and MR, mixed reality. Unlike AI or quantum, which are largely invisible systems working under the hood, spatial computing changes how we experience the digital world. Augmented reality, AR, digital objects overlaid on the real world. Think Pokemon Go or AR dashboards. Virtual reality, VR, fully immersive digital environments, like MetaQuest or Valve Index. Mixed reality, MR, digital objects that interact with the physical world. HoloLens or Apple Vision Pro. Spatial computing combines these with gesture recognition, eye tracking, and voice commands so you can interact with computers naturally without a mouse or keyboard. Real-world examples: surgeons navigating holographic hearts during operations, architects walking clients through buildings that aren't built yet, virtual meetings where colleagues appear as life-sized holograms. Bottom line, spatial computing makes digital interaction spatial, immersive, and intuitive. It often uses AI to recognize objects and gestures. Quantum, not really involved yet. But as quantum advances, who knows? Complex simulations in spatial environments could eventually need it. So why does everyone get confused between AI, quantum, and spatial computing? 1. Marketing hype. Tech companies blur the lines to sell products. AI-powered quantum headset sounds exciting, even if it's mostly marketing fluff. 2. Sci-fi influence. Movies and media mash concepts together. Sentient AI, quantum consciousness, immersive VR. It looks real, feels real, but is misleading. 3. Ego and assumption. Engineers and experts sometimes bluff or oversimplify to look smart, and everyone nods along. The result? Most people, including some professionals, think AI is magic, quantum is a brain, and spatial computing is just VR. None of that is correct, but now you know the truth. Here's your final takeaway. Computer equals hardware, the machine that executes instructions. AI equals software, algorithms that detect patterns and make predictions. Quantum computing equals new type of hardware for specific hard problems. Spatial computing equals immersive, 3D interactions between the digital and physical world. Simple, clear, no more pretending. So next time someone confidently says, AI is just a computer, or quantum is super AI, or even spatial computing is just VR, you'll know better. If this breakdown helped, hit like, subscribe to Beyond Tech Hype, and share it with that one friend who definitely already knows. Because in tech, the real danger isn't ignorance. It's thinking you already understand when you don't. And I'll see you in the next video, breaking down innovation one myth at a time. That's it for today. Beyond Tech Hype is all about cutting through the noise and getting to the real story behind the buzz. If you found this useful, hit that like button so more people can see it. Don't forget to subscribe and turn on the bell so you won't miss the next myth we break down. And hey, share this with someone who still believes the hype. Let's build a smarter conversation together. This is Beyond Tech Hype. Understand the innovation.